Hello guys, welcome to Zip Code, and if you're new to the channel, we welcome you with great happiness, and we hope that you stay tuned and become a subscriber. And if you're coming back, welcome back to the channel, and we looking forward to keeping you happy, keeping you entertained, and also learning and improving your development as well as projects in your daily coding. So essentially today we're looking into Kafka and how we can integrate or utilize Kafka in our Springboot project to develop and deploy or deliver high performing applications using Kafka and Springboot. So essentially we're going to cover what is Kafka, how is it utilized, and how we can set it up in our machines. And in this video we're going to look at a Mac OS Kafka setup, but first we're going to start by the introduction and what it is, and without wasting any of your time, let's just go through what Kafka is. So essentially Kafka is an open source distributed system which is run as a cluster. So Kafka essentially is an event-driven distributed system. So what it does is assist us in creating event-driven applications. So event-driven means if we have microservices, IoT devices, APIs that need to be kicked off or triggered based on specific events from other systems or other integrated devices. For instance, if we take a vehicle or a car tracking system, you will see that if you have a tracker in your car, there are a number of events that are based on that particular tracker. For instance, if we take a car crash, your sensor device would essentially trigger a crash event that would basically notify your app, notify the agents at the office so that they can assist. Even with some other trackers, they can trigger emergency services as well. With the likes of Mercedes having those particular type of trigger events being available with just a click of a button, or with all of these sensor installed within that particular car, or there are other brands that also do this, not just that one I just mentioned now, but these are event-driven scenarios that I'm just showing you where Kafka can be useful. So essentially it consists of servers and clients that interact via high TCP network protocols. So you have producers and you have consumers. So in a Kafka setup, you would have a producer that sends an event or a message into a broker or a topic, and then that particular topic, any consumer that is subscribed to that particular topic would then get that event, and it will trigger another process, or it will trigger in the case of a car tracking company, the agent will then try get in contact with you, try to get emergency services for you, and things like that. So Kafka utilizes brokers that stream data or events from the producers, to the consumers that are subscribed to a specific topic. So specific topics deal with specific events, and that keeps the process cleaner because you know what particular event does based on the topic that it's subscribed to. So specific events are streamed into specific topics that is shared across all brokers within a cluster. So a cluster is basically um, um, a set of a minimum of 3 brokers, and then the topics will be streamlined across those, shared across all those brokers, so that if one broker fails, then it can fail safe on the next broker that is available. So essentially that's what that is, and let's go further and see in detail. So with the highlights of a Kafka cluster consists of a set of brokers in which It consists of a topic for specific events, and that will have a fail-safe mechanism, because the topic will be across all the brokers within that cluster. And if one broker fails, it can use the next available broker, and it should be fine. And the messages and the process should not be disturbed in any way, shape, or form. So basically, a cluster would have a minimum of three brokers available. And then looking at the diagram or the Kafka architecture. So from the far left, we have messages API or IoT. So this could be a microservice that is triggered, or an IoT device that received an event in a vehicle sensor or a car sensor. It will have that crash event that happens. Then it produces a message to the cluster or to the broker or to the topic, and then that particular message will then be consumed on the other side, or pulled by the consumer from the far right, by consumers that are subscribed to that specific topic within that cluster. So all the consumers that are basically subscribed, they can be able to pull that message and interpret it in their particular form or process to trigger other events or kick off other processes at the end. So you can persist the data in the database. You can then trigger the agent to call the client, make sure everything's fine, everything's sorted, and the crash event is attended to as needed. So now we have covered essentially in summary what Kafka is, what it does, and what are the nitty-gritties within the Kafka architecture. Let's just go and see how the docs are in the Kafka side. So basically, from the Kafka website, you can just go to your browser and just say Apache Kafka, and then you just click enter. Then the first link that's going to show up will be Apache Kafka. We just click on that. And first thing that you see, they mention Apache Kafka is an open source distributed event streaming platform used by thousands of companies for high performance data pipelines, streaming analytics, data integration, and mission critical applications. So with enterprise applications, Apache Kafka is very key in streamlining a lot of processes that are event driven. So if one event happens, kick off the next process, kick off the next process, kick off the next process. And that's essentially how Kafka ties everything together in that sense. So we can also go to the docs and see what they have here, and you can just go through it, and it will be very handy in terms of assisting you understanding the finer details of what Kafka is and how you can set it up and which use cases you can apply Kafka to. So an event that triggers or pushes a message, so it's publishing, as they mentioned here, to publish, write, and subscribe to read. So producers publish and consumers subscribe or read stream of events, including continuous import or export of data from other systems, to store streams of events durable and reliability as long as you want, to process streams of events as they occur, or retrospectively. So basically, if you saw in the architecture, it covers these three particular points, and that is the essence of what Kafka is. So you can dig deeper into the docs and get an understanding of what it does and how it can be useful on your project. So now we are going to go further into setting up Kafka on our machines and see it in action. And let's just do the setup, and then we'll cover the project in the next video, and you'll see it live in action. So we're just going to click on download Kafka right here, and we want to download the source download over here. So we're going to click on Kafka 3.5. Then we want to take this to let's go to downloads. Downloads right here. Then let's save this. So now that is fine. Let's just go to that. Just go to downloads, and let's go there. And let's extract this, and we will this. We need that. Okay, so now that is done. So let's just close this. And let's also close this. Okay, let's just rename this. We want to rename that. We'll just call it Kafka, and it's fine. The downloads, there's no problem there. And then we are going to, so those are the release notes, and if you want to see the step by step, we'll just go to the quick guide and we'll follow the Apache Kafka quick start tutorial, and let's just go right into that. So we already got Kafka, and now we just need to do as they say here, and we are going to open a terminal right here, and we just need to, all right, we need to cd downloads, come on, downloads Kafka, and yeah, that. Okay, now we're in Kafka. So as I said here, we just go to that folder where our Kafka is. And then the next thing is we want to start the Kafka environment. So if we go to Kafka folder bin, then we should see these files available there. Then it should kick off the Zookeeper server. So let's just do that. So we're just gonna copy this command right here, copy that. And before we do that, we're just gonna go inside that, and we want to see in the bin folder right here. So in the bin, we should see Zookeeper, Zookeeper server start.sh is there, and Zookeeper dot properties. So let's see Zookeeper dot properties. So that one is in config. So let's just go to config, config, and Zookeeper properties is available here. So it's going to start the Zookeeper server using the Zookeeper properties, and then let's just paste that right there. Just click enter. So class path is empty. Please build the project first, e.g. By running that particular command. So we're just going to run the command as it tells us. So we're not going to make up anything. And we just go into Scholar version. I'm happy that this is coming up, and anything that you see on your side that is going to come up, you can just address that particular issue at that level. So we're just gonna wait for it to download, and once it's done downloading, configuring and everything, then we proceed with the setup. So right now it's quick because I did have an initial setup that I got rid of. So I'm pretty sure it's just picking up all the downloaded artifacts that I had, and it's just configuring as quick as possible. But on initial setup, this will usually take up some few minutes, and you will see it up and running after we run our command to start the Zookeeper server again. But also, I think there was one talk that I saw here where there were, let's say, allegedly wanted to remove the Zookeeper setup. I don't think in the future releases it will be required to be there. But yeah, we'll see how that goes. But for now, this is how we essentially do the setup. And let's just see, it's okay, 68%. It's not not so bad than my initial setup. That took a few minutes to set up, but now it's super quick. So once the Zookeeper server has started, we will then open another terminal session, and we'll just execute this particular command, and then we will see what that looks like in a few seconds. So let's just wait for this to finish. Or we might as well just open a new one. I don't know, let's just open a new window as well. Let's just put it here, and this one can just sit right here so that we see both of them over there. So here we can just cd to Kafka, cd to downloads, Kafka, and then we paste that right there. So we'll just wait for the Zookeeper to start up first before we can then um, execute this one. So let's just wait for that. Let me just make sure that I have this one available, so that when this is done, I just execute the Zookeeper. And let's see. Come on, come on, come on. You're almost there. You're almost there. It is taking a bit of time. But yeah, essentially, once our server is available, I think the default port is 1992. So it should be available on localhost 1992. And once we plug in um, our broker in our Springboot application, you would then be able to see all those calls that we're making to the Kafka, and also configure a consumer to receive the messages that we'll be pushing. So essentially, how that project is going to look like, let me just give you a run through of the initializer right now. So I have this Spring initializer set up. So our project is going to be Maven. The language obviously is Java. Then I always recommend use the latest stable Springboot version. So we are on 3.1.3. That's what we're going to be using in the next video. So just stay tuned for this video. After this overview and installation, we'll go through the code. So I want to keep it short and simple. Whilst we wait for this to finish, we're essentially just running through the project already. So the group is zip code, so artifact event com. So I will share this in the next video that is coming up, and you will see the config in the description down below. So we have a few dependencies, Spring Boot DevTools. So we want to have a live reload here. We don't want to be starting up a server each time we make changes. And then we're going to have Lombok to try and minimize or utilize Bootstrap and boilerplate code that is available for us. So we're going to have Lombok. But essentially what we need is Spring Web, and we have Spring for Apache Kafka streams. That is basically the two dependencies that we are going to need, and nothing else. So these are just fancy dependencies that are there for our convenience. But we'll be using Spring Web and Spring for Apache Kafka, and essentially we'll be using that. So yeah, let's see. Let's just wait, and so it's still in 91%. Taking its time. So once we have these, we'll then configure our producers, configure our consumer, and then we'll start using an API that will be available to us that we are going to create, and then basically we'll push a message to a topic that we'll create in our Kafka on our Kafka broker. And then once we have that topic or our Kafka cluster, we'll have that particular topic. We push or publish messages to that, and then the consumer, which will be our API, expecting it at the other end, and then we will see how that integration all ties together in the Springboot world or in the Java world. So yeah, let's just wait and see if this is done. So we're at 94%. We are almost there, so essentially winning. But once this is in action, then it should be easier for you guys to now start utilizing Kafka to wait for specific events or subscribe to topics or produce to topics and third party systems that integrate to your system or to your application can also subscribe to that particular topic, and when that particular process kicks off, they can expect events to trigger their APIs or their systems on their side to push data, to store data, and the likes. So that is what we want to achieve in this project right here. So let's just wait and see if this guy is winning. So the setup is essentially should be fairly quick, but on my workstation, I essentially do not have that particular dependency that it is complaining about. So once that is set up, it should be fine, and I should be able to then start up the Zookeeper and start up the Kafka server without any issues. So let's just give it a few more seconds and see. It should be coming along fine. So this config I will share even in this video down in the description below if you already want to start that up, and as soon as that is done, then you can jump onto the next video and see the code and how you can use that. And we'll see this also in the docs or on Springboot, Spring.io, on how to basically set it up. I'll also share the docs on the code side to create a producer, to create a consumer, and basically interact with your Kafka topics. So we're gonna see that in action as well, and hopefully you get a much broader understanding of how to deliver event-driven systems. Let's see, it's taking longer than I anticipated. We're just gonna wait for a few seconds. Let's see, should be done by now. Let's just see, because now it's going to be delaying the process, and it shouldn't be. 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 Let's see. So let's see the next step right here. So now that is done. So if we want to create a cluster UID, this will be the next step. Cluster UID, bin Kafka storage, random UID, and then we'll have a cluster UID available. Then we can format log directories, start the Kafka server, which is basically the first command that we use. Once the Kafka server is successfully launched, you will have a basic Kafka environment running and ready to use. So for now, we're just using default startup. So basically, this is Kafka with with Raft or Craft. So basically, that's that, and we should basically have our environment, create a topic, and we can just use that to create a topic. And as you can see, the broker is localhost 1992 is the default, and obviously based on your requirements. You can set it up or change it to whatever that you need it to be. So once you create a topic, then you'll have producers to the topic and subscribers to the topic, which will consume an event that is pushed to that particular topic. So let's just see if we are winning. All right, so build successful, everything is fine, and then now we are going to run our zookeeper. Startup is H. Let's click enter. Let's just say this. Boom, 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 and our zookeeper is coming up just fine. So that looks good. No complaints, nothing. And then now we're going to the next terminal. So if we go back here, just to show you, and we are, so this step is now done, and then we are on this step. So open a terminal session and run this command. So this is the other terminal session. Then we're just gonna run this command. Click enter, and let's just wait for it. Wait for it. All right, broker. So recorded new controller. So you can see here, recorded new controller. From now on, we'll use node localhost 1992. So now our Kafka is ready. It's set up. It's available for us to use. And as you can see on the docs, it's already telling us once all services have successfully launched, you will have a basic Kafka environment running and ready to use. So the environment is now ready to use. The only thing that is left is for us to now create a code, create a project, and then start utilizing Kafka and see this in action. So we're not going to run through the other commands, but we will do them as we go along and go in the Kafka topic, and we will see more as we go along. So for now, this is the setup, and I hope you now understand the Kafka, what it is, how to set it up. In Windows, you follow the same steps just for Windows, and it should essentially be the same setup, as nothing too complicated. And I hope this was helpful to you. Hope that you like and subscribe, comment, and share the video. But for now, till next time, cheers.